All right, I just want to make a quick review over chapter 1, since we, reviewed the other day and did, obviously you guys had the quiz. So here we go, chapter 1 stuff. All right, so remember we started out with graphing. The easiest way I think to graph is to sub in zeros, so intercept. So if x is 0, do you see how you can divide by +6 and get a -2? If the y is 0, you can divide by +2 and get a -6. So I am going to put a point -2 on the y-axis and a -6, 1, 2, 3, 4, 5, -6 on the x, and I'm going to draw my line. Okay, and there are other points too. So if you want to just sub in another value, you can. I would probably try to pick even numbers since you have all even numbers here. But for example, let's see, if I sub in a 1 for, let's see, for y, 6 times 1 is 6, subtract it over, I get a -18, divide by 2, -9. So at a -9 1, I would also have a point. If you really love to solve for y and do the y-intercept, rise over run, you can do that if it works for you. Okay, I prefer this. All right, say that, let's see, let's do this next. We'll come back to that later. Say an item costs, sorry, I can't talk today, $10 to make. And let's say you sell it for $30 and you have a fixed cost of, let's see, $100. Okay, and I want you to write the cost function, revenue, profit, find break even, all of that jazz. Okay, so remember, revenue is the easiest because that's just the money you're bringing in. Okay, and we're not selling them for 300, we're selling them for $30 per item. So that is your revenue, 30 times X, because that's just the money coming in. Okay, cost function is your marginal cost, okay, the cost to make 1 per item, and then also your fixed. Okay, so this is costing you $10 per item to make, so that would be 10x, okay? And then you have a fixed cost of, say, $100 for some type of machine or something like that, okay? And then, so that's money going out. Profit, I think the easiest way to view that is to think of your net. If you charge $30, but it costs you $10 to make each object, the net is that you're profiting $20 per item. The other thing is when you start a business, you start out in the hole. So that fixed is debt until you get out of debt, right? Okay. Another thing you could do is take all the money coming in, 30x, subtract, and then parentheses 10x plus 100. You could distribute the negative, and you still are going to end up with 20x minus 100. Okay. Now, break even point. This is when you've paid off all your debt and you're going to finally start showing a profit. So one option is to say, well, then my profit is really 0. So 20x minus 100 equals 0. Add the 100 over, divide by 20, and you get x equals 5 items. So you're going to have to make 5 items to pay off the $100, basically. Another thing you could do is set revenue equals to cost, because revenue is money coming in, cost is money going out. And you could solve that equation. You're going to end up in the same place. Okay, either way works. All right, say that your fixed cost is $500 and say 10 items cost $600. Let's see, $600 to make. Okay, and I want a formula for cost. Okay, so if you look at this, remember you can either be the chart person where you take the total cost, $600, you split it into the ongoing, which is your marginal cost times X, the number of items, and the one-time expense, which is your fixed. So I know this time my fixed is 500. So if I subtract from 600, I know the other part is 100. 100. All right. So the 100 is for the 10 items though. So I'm going to take that 100 divided by the 10 items, and that's $10 per item. That is my marginal, because marginal is your cost to make one. So my cost function, C of X, equals 10X plus the fixed 500. If you love algebra, Y equals MX plus B is your go-to. You know input, you know output, and what else do you know? You know B, you know the fixed. Sometimes you know marginal, sometimes you don't. This time we don't. So my fixed is what? 500. My input is 10. I'm going to put that under the X. I don't know M, so I'm going to write it equals, my output is $600. Solve your algebra equation. So instead of adding 500, you're going to subtract it. 600 minus 500 is 100. 10M. Divide by 10. M is 10. So my marginal cost, I get 10 either way. So then you write your cost function, C of X equals your marginal cost, 10X plus 500. Okay. All right. The other thing we did in this chapter was supply and demand. So say supply is P equals 0.4 Q quantity, and say demand is P equals 120 minus 0.8 Q. So the supply was the first one I said, demand is the second. All right. So here I could ask you to find the equilibrium price and the equilibrium quantity. And again, if things are equal, they're balanced. So I am going to set my supply equal to my demand function. So I have my two functions. I'm going to set them equal. To solve, I am going to bring my Q's to one side, my number 120, which is on the other side. I'm going to divide by 1.2. So what is that? Is Q, is that 100? I think so. I think it's 100. We'll check in a little bit here. All right, so that looks like it's 100. All right, and remember, quantity might be in sets of 10, sets of 100, sets of 1,000. So just, just kind of look at the context a little bit. All right, so the quantity is that, and then I can substitute it into either equation, doesn't matter, sub it into either one, and 0.4 times 100 would be $40. So when my input, if I made an order pair, it'd be 100 for my input, and then $40 for my output. The other way you could check this on Desmos is you could graph these, right? And see where they cross. That would be your equilibrium point. And you could do that as well. All right. Let's look at pivots. We did that actually the other day. Okay. Let's look at the other thing in this section would have been, say, like doing linear regression and finding your R value. All right. So remember that if I want you to do linear regression, I want you to use Desmos so you can edit the X values. So 5.8, 1.5, 2.3, 1.0, and 3.3. And then enter the Y values, the output 8.6, 1.9, 3.1, 1.0, and 5.0. And we're going to do linear regression. So the input is the width of an egg of a bird. The output is going to be the length of the egg for that given bird. And then we're going to do something with that, right? Like I'm going to ask you questions. All right. So I'm going to pause here for a second. I'm going to get this entered into Desmos and see if you remember how to do linear regression on Desmos. All right, so remember, you go to Desmos graphing, you hit the plus sign to get the table, then you're going to enter your data, and then remember you come down and do y1 tilde m x1 plus b. So I'm going to pause, you go ahead and type that in at the same time. We'll make sure we can get this. It's not pausing, here we go. Okay, so I typed in the data, hopefully I did that right. New line, I did y1 because you want it to use all the y's to figure it out. Tilde m x1, you want them all to be in the problem plus b. And when I do that, I got M equals 1.585 when I rounded, and B equals what? A negative 0.487 when I rounded. And your R value, which tells you how good your data is here, R is or how strong the correlation is, 0.988. That is almost perfect, right? 1 or a negative 1 would be a perfect correlation. That's pretty close, okay? So then what we're going to do is we're going to use that to answer some questions, all right? So if I go back, say I ask you, so I wrote my equation, y equals, subbed in the m number, x plus, subbed in the y-intercept number. So say I tell you the width of an egg is 4.6, okay? You have to ask yourself, is that input or is that output? And if I go back to our chart here, where was it? The input was the width of the egg, okay? So I'm gonna sub the width in here. And you can just type that in a calculator and, get an answer. So I'm just gonna use my phone calculator here. So I have decimals on my phone here. So I have 1.585 times 4.6, and then what? Plus a negative 0.487. So about 6.8, I believe it was, centimeters would be the output or the length. Here, the second question, I'm giving you 7.8 centimeters as a length. That is your output. So you're going to put that into your formula where the output goes. Now, in algebra, you always get rid of adding or subtracting first. So you're going to add that 0.487 to both sides as a positive. So I'm going to take 7.8 plus 0.487, and I get 8.287. And then I'm going to divide both sides by the slope, 1.585. So I'm going to take my previous answer and divide by 1.585. Oh, maybe if I put the decimal in there. Hopefully that's right. Okay, I got about 8.1, I think, if I type that in right. And that would be centimeters. All right, so those are kind of some of the quick problems I wanted to go over from that one. I'm trying to think if there's anything else. Let me pause for just a second. Okay, I did have a student ask me to do another total value comparison one. So this is on our sheet. This is problem number 53, and it has money, percents. It says 1,000 more, so that's a comparison. All right, so I'm going to make my chart. I'm going to pause, and then I'll talk through that quick. All right, so in this story problem, they say there's a total of 25,000 invested. So X plus Y plus Z equals 25,000. Interest rates are 8%, so X, plus 9% Y, plus 10% Z, and that should equal the interest of 2,190. The comparison says that they borrowed 1,000 more at 9% than 10%. So you know that they borrowed more at 9%. So 9% is the big number, 10% is the small number, and they borrowed what, 1,000 more. So equal signs are like teeter-totters. So if I set these equal, you need to add the 1,000 to the smaller number to equal up to the bigger number. So if you add 1,000 to the bigger, it just keeps getting bigger. An equal sign is a balance. So I'm going to add 1,000 to the smaller number, okay? Because it says they borrowed more at 9%. That's your Y than they did at 10%. So you add the 1,000 to Z to equal the Y. Now, to get it to line up, I need to bring the Z over to the other side. And again, in algebra, when we bring things over, we add or subtract it over. So I'm going to get Y minus Z equals that 1,000. So when you make your matrices on that bottom row, you're going to have 0 X's. So you're going to have 0, 1, negative 1, 1,000 when you make your matrice. But to set up that comparison, you kind of have to think a little bit. So your matrice top row would be 1, 1, 1, 25,000. Second row, 0.08, 0.09, 0.10, 2190. And the bottom row would be 0, 1, negative 1, 1,000. and then do RREF on that, and it should spit out a beautiful answer. All right, hope that helps.